Well, good afternoon, everybody, and welcome along to Data Platform Down Under for the month of November. Normally, it's both Martin Catherall and myself being your hosts, but for this month, Martin's actually going to be our presenter, and he's going to take us through from SQL to DAX. Now, this session is being recorded and will be made available on the Data Platform Down Under YouTube channel. If you aren't already a subscriber to the channel, feel free to subscribe to the channel where you're able to come back and rewatch this session, as well as all of the other sessions that we previously have hosted. I will look at putting the link in the chat window so that you are able to know where to go. Throughout the session, I will be monitoring the chat. So if you do have any questions for Martin during the session, put them in the chat, raise your hand. If you can preface your question with a capital Q in the chat as opposed to a comment, then that makes our life a little bit easier to identify that, and I'm able to put those questions through to Martin appropriately. So with that, I'll hand it over to you, Martin.
Okay, thanks a lot, Warwick. Let's get my slide deck up and we'll take it away. Okay, so yeah, like Warwick said, any questions and also comments. So comments might be appreciated there. Anything you see that seems relevant, just shout it out, Warwick, and we'll give it a talk about. So I'm Martin. Obviously, I run the group with Warwick. I'm a co-host, based in Brisbane. Been doing SQL, Azure, and Fabric for the last 2 years, which is quite interesting, and maybe we'll touch on a little bit of that today. So let's start off by saying, let's play some guitar. Okay, so you're a guitarist and you can play the guitar. You're pretty good at it, and then you come and see your band rehearsal one day. And your manager says, well, you know, we don't want you to play that guitar anymore. Can you play this one? And you're like, well, you know, what makes you think I can play that? And he's like, well, you know, it looks the same. It's a guitar. And you're like, it's only got 4 strings. I can't. It's obviously different. And he's like, oh, very surprised. So, you know, naturally, you're going to be great with this if you're great with the other one. You're like, very surprised. And then there's even more subtle differences where, you know, you can play this guitar. So, you know, you're great with this. Surely you can play this one as well. Or maybe even this one. And you're like, okay, I'll give it a go. I'll play any of them. And then you discover that they're not quite the same. You normally used to play with standard tuning. You've got different tuning on the middle one and different tuning on the end. So my point really here is that just because one thing looks like another, it's probably not the same. And this has caught me out in IT. I wouldn't say loads, but occasionally it does catch me out. And I know it catches other people out as well. So I just wanted this to really be a session about that as the main topic. But obviously it's really related to like SQL and DAX, which are probably 2 of the main things in our industry where people go, you know, you can do SQL, therefore you can probably do Power BI and you can probably do DAX as well. And for a big part, that seems a reasonable assumption until you get into some of the nitty gritty and find out that that's not actually quite the same. Just because one thing looks like another doesn't mean that it is really the same. So ask a rhetorical question here. Obviously you don't have to type in the chat, but you can if you want. What have these things got in common? So we've got like SQL Server on-prem, kind of any edition you like. Take any edition you like and look at what it's got in common with any of these other things. So we've got Azure SQL Database. Obviously, a lot of commonality there. T-SQL would be one of them, but that's not really what I'm looking for there. And then we got Managed Instance. So Managed Instance, obviously cloud-based database as well. Very similar to Azure SQL Database. And I actually think at the minute there's like close to 100% coverage between Managed Instance and SQL Server on-prem. I'm not 100% sure of that, but I think that's right. But anyway, all them three things have got one thing in common. And there's another thing here that's got something else, well, same thing in common. Synapse serverless pools and Synapse dedicated pools. We got Fabric lake houses and we've got Fabric warehouses. And they've all got one particular thing in common. And that is that they've all got T-SQL endpoints. And they're all not the same. So just because something has a T-SQL endpoint doesn't necessarily mean it supports all the features of T-SQL. One of the things that caught me out in my career once was picking a on-prem data warehouse up and trying to, well, migrating it to a Synapse serverless SQL pool. Or it might have been a dedicated one, I can't remember. But anyway, all went swimmingly well up to a point. Tables in there, stored procedures, most of them worked okay. And then we come to things like multi-value table functions that aren't supported in by the T-SQL endpoint or Synapse serverless as a whole. And it's like, oh, well, we can't really take them across. There's no one-to-one match. And I see a bunch of people making the assumption that just because something's got a T-SQL endpoint, naturally the assumption is that it implements all of the functionality of T-SQL. And that's kind of more obvious with the Fabric Lakehouse. So Fabric Lakehouse obviously does provide a SQL endpoint, but the only kind of SQL functionality it provides is kind of looking at data. So you can select and you can actually look at system tables in there through the SQL endpoint. Not all of them, not all system tables and that are available, but you can look at most of them. Most of the things you might expect, simple things, through that endpoint, view data, but you can't really manipulate. Well, you can manipulate data if you just want to look at it, but you can't insert, you can't change, you can't delete, you can't do any of that through the SQL endpoint. And so you're going to have to learn Spark SQL or Python and do it through something like that, which is kind of pretty straightforward. You probably end up Googling a bit of syntax difference between T-SQL and Spark SQL or PySpark, data frames, things like that. And you probably, after a bit of a while, you'll tend to figure it out. And Fabric Warehouse, that does support writing to the warehouse using T-SQL endpoints. Again, not the greatest of coverages. A lot of the things you'd expect to be there a day, things like window functions, and quite a lot the T-SQL surface area, but not everything. So kind of it's a bit of a departure from like the SQL DAX thing, but it's kind of just an example of some of the things that you might want to be aware of in IT generally. So then we look at things like this, Cosmos DB. So what's that got in common with Azure Data Explorer? What's that got in common with Excel? And what about DAX, data analytical expressions, which obviously we're going to delve into a little deeper very, very shortly. And Power Query as well. So what have all these things got in common? So people will describe them as SQL-like languages, but how much commonality have all these things got? So Cosmos DB, that's got what is described as a SQL API. Well, actually, it's more like a NoSQL API. Yeah, you can do things. You can select data, and you can do some rudimentary stuff that you'd expect to do in T-SQL itself. But then you're going to come to a point at some stage where it diverges quite sharply from SQL itself. Same with Azure Data Explorer. Although that point might be a bit further down the line. Lots of SQL-like syntax in here, even though it's called KQL, Kusto Query Language. It is very similar, but then you'd also get to a point somewhere along the line where it's not quite the same as SQL. It starts diverging a lot. I'm thinking things like, say, a union statement. yeah, a union statement does what you expect, but how you do it, and it's actually got additional functionality in there for that statement to say which branch things came from, and things that could actually work quite well in T-SQL itself. But that's just one example, and then it starts getting a little bit away from the normal syntax you'd expect. Not in a bad way, maybe in a good way. You'd think, oh, some of this stuff could like be really useful in T-SQL itself, but it is different, and you're gonna have to like do some Googling and um, and look at how things work. Excel, obviously, I mean, most of us have played with Excel. It's very unlike SQL, but it still manipulates data. Obviously, it's just got cells, maybe instead of tables, but you can obviously create tables around the cells and treat things like tables. Um, and that's probably got more in common with DAX itself than maybe SQL, maybe a database. As we'll see, like lots of the in Excel, you've got obviously cells, and each cell's got really its own kind of um, function behind it, and that kind of isn't true in DAX. You can think about the cells having their own function behind them, but it might not be kind of obvious that that's kind of what happens. And then we got Power Query. So Power Query, obviously in Power BI, um, it will drag things in with it. We'll acquire our data through Power Query. And for the most part, we're not really creating tables or doing anything like that, but we can create our own tables. We can manipulate the stuff we drag in. The syntax is, yeah, it's not really SQL like, well, it's M. It's you can do similar things to what you could do in SQL or SSIS. But it's a kind of a different kind of language. And again, you'll be fine up to a point, and then you'll start diverging away from your SQL know-how. So a lot of commonality, a lot of difference. And one of the things that kind of brought me to this talk was bumped into, I've ended up taking on a few DAX problems. I'm not diving into Power BI in any sort of big way, but taking on a few DAX problems and looking at the language and having to go back to basics and things like that. And how I've come to have those tasks is people have like assumed that, oh, Martin knows a lot about T-SQL, maybe he can just like dive into DAX. And what I hear all the time is it's a SQL-like language. And okay, it does a lot of similar things. You know, in reality, it's got rows, it's got columns, and all those things we talked about before, Cosmos DB as your data explorer, Excel, DAX, Tabular, Power Query, you know, rows and columns. And just because something has got rows and columns doesn't mean necessarily that it's a SQL like database. So they all implement certain SQL keywords, or do they? We'll have a look at that. Or they've got different keywords that do similar things, but they maybe behave in a different way. And when you got like your SQL hat on and you're looking, oh, does this really behave like I expect it to? Like even something trivial like I'm just selecting some data from here. I'm maybe grouping by it. So I expect it to work in the way it would work in T-SQL. And then it absolutely doesn't. And that kind of leads you to the conclusion I've either done something drastically wrong or there's some sort of bug here that I've just hit and no one else has. Both of which would probably be wrong. It's probably more to do with the way the language or the engine works behind the scenes. And that kind of just leads to a lot of frustration. So I guess to reiterate, your SQL knowledge is useful, but it'll only get you so far, unfortunately. So what? How did I come to do this talk? Really? Well, just like I say, just I've dived into DAX a little bit, and like I end up diving into it, and then I'll work on it for maybe a week or 2 weeks or something. I'll get quite into it. I'll solve the problem, and then I'll never see it again for, I don't know, maybe 6 months or maybe never. So the talk's really more around the green the green circle, which is the modeling and the syntax of DAX. But we can't really talk about DAX or tabular without really talking about the whole Power BI thing, you know. I've never really seen anyone implement like a tabular database or that without putting something like Power BI over the top. For example, you've probably seen SQL databases where people have implemented them. There's a whole range of, you know, things they use to talk to the database, or you know, they might use Visual Studio, they might use SQL Server Management Studio, they might have their own custom app, they might have Cosmos, they might have a whole range of things that tap into like their database, whether it's like transactional or data warehousing or whatever. It's very, very generic SQL. But in terms of tabular, you know, you implement tabular, you're getting on for 100% likely to be using Power BI or something like that as well. So the two things are really kind of quite intrinsically linked. But as a developer or not, yeah, okay. So I want to know how to use Power BI a little bit, but I'm never going to be a great Power BI developer. I haven't got the want to be able to design really whiz-bang visualizations. Other people can do that absolutely brilliantly. And while I can create, you know, reports and that, they're never going to be totally brilliant. They're never going to blow someone away, which is actually what you really want when people are implementing Power BI. So I broke it down into three main areas, really, into like the visuals of Power BI, whether that's like a pie chart or a line chart or whatever it is, the visuals. So that's one area. The other area is like the Power BI service and administration in general. And you could probably extrapolate that out to like the Fabric service and Fabric administration. I actually think that area in itself is going to become a very big area, and probably people are certainly in bigger organizations are going to have just the one job of administration and looking after the service. There's a vast array of administration features going on in Fabric at the moment, and there's probably too many for, you know, for one person to do development, administration, modeling, and all that at the same time. But, you know, in terms of doing the modeling and the syntax, we're going to sort of overlap with the visuals. We're going to sort of overlap with the service a bit. But essentially, we want to concentrate on the modeling and the syntax. So them two things in itself seems to be a bit, I don't know, bit alien to how people might go about with databases. For example, if you wanted to learn T-SQL from the ground up, you know, you're only really interested in the syntax itself. You know, how do I query a table? How do I join the tables? Maybe at a stretch you could consider that modeling, but I'd just say syntax, left join, right join, join, whatever it is. Just the syntax of T-SQL itself. The model itself, the relationships under the surface, the primary keys and the foreign keys. Yeah. You obviously need to put them in, need to know what they are. But in terms of getting data out, obviously it's all about the syntax. And as you get more skilled, you're obviously going to want to know how things work under the covers, do I implement indexes, and all that sort of thing. But in tabular, Power BI, whatever you want to call it, the modeling and the syntax are very, very closely related. And that's one of the first big differences. So I kind of put my SQL hat on and I thought, well, you know, when you were learning T-SQL, what was the way you wanted to do it? So let's learn some DAX. Right. So does anyone remember this, or, you know what it is? Obviously, it exists in SQL Server, and it is a really cool feature of learning T-SQL itself. So here we just got like how to back up a database, and the dialog box is obviously very, very common across a lot of the other dialog boxes within, say, Management Studio. That's where it comes from. So you got the script button at the top. So we obviously get the dialog box up. We put our parameters in. We press the script button, and we get our T-SQL script. And then we can take that T-SQL script, we can run it, we can examine it, and we're now that, okay, I wanted to do a backup, and I've got this T-SQL, and that's great. And that is a phenomenal learning tool, not just a cheap shortcut, but it can be. It's a really good learning tool. So I'm sure lots of people have learned a lot of T-SQL like that. I've certainly sharpened my skills doing it, and I still do it to this day, as I'm sure most of you do. So what I'm thinking is, if I can do this in Power BI, I'm kind of on my way to learning DAX, so I'm looking good. So let's do the same in Power BI. So let's go over to a Power BI visual, and we'll open up a Power BI dashboard. It doesn't really matter what this dashboard is. I got this from the Dashboard in a Day course, which is publicly available. So what I want to do is something similar in Power BI to what I've just done in SQL Management Studio. So what I'm going to do is go up here to the Optimize tab, and I'm going to press this button, the Performance Analyzer. Nearly pressed the wrong button. And I'm going to start recording, and I'm going to click around. Just click around on different visuals, and you'll see that obviously there's things changing in the Performance Analyzer panel. So what I'm kind of want to do now is try and find a visual. Obviously, there's a lot going on here. So we see coders for the slices, for different visuals. I'm just going to pick a visual at random, and it doesn't really matter what it is. So I'm going to pick this revenue and PY sales. And you can see there's a whole load of things that have got come down here. There's a DAX query, there's the visual display. You can copy the query, or we can run in DAX query view. Now, Power BI recently has implemented a DAX query view, which is quite useful. So I'm just going to click on that DAX query. And that DAX query has come over and has landed in my DAX query view. And I'm kind of thinking, yeah, that doesn't look anything like SQL at all. So I've run it. You can see it's obviously ran. It's returned a number. So let's run it again. Yeah. And I'm already a bit lost here. I'm expecting to see something like a select keyword, or maybe a where clause. I see something called summarize there, which I can guess it's doing some sort of group by or something. It's returned one record, so I'm guessing it's done some sort of group by. Sorry, just needs to get a drink. And it's kind of really curious. And it also implements this keyword here that I've heard a lot about. I've heard a lot about this calculate keyword. People say, if you're gonna know DAX, you need to know this calculate keyword, and there I see it. I don't know what it does yet, but I see it there. And then I've got these things up the top. I'm assuming these are variables. And are they used in my code anywhere? So I've got this thing here, so I can kind of see the variables come in here. I'm kind of curious about this, it's not how I would go about designing a SQL query at all. Well, I might use variables, but it certainly would not look like this. The long and short of this is we can define variables, and the variables can actually be tables. So we could define our own table up here. We'll have a look at doing that shortly. And then once we've defined our variables up here, even measures, we can even define our own measures up there. We need to put them into what you might say in your select statement, which is basically your evaluate. So as soon as you've got evaluate, the query, so to speak, follows that. So we hit evaluate, and then we're summarizing our columns, and obviously we're getting back our sum and our sales amount. So that's kind of pretty useful. Obviously we don't know what's going on yet, but it's similar to what happened in Management Studio. So let's look at some more interesting features. I just want to bounce around and look at things that I discovered that I really went, oh, that doesn't sound right. That doesn't look right. So let's look at the next thing we've got, which is our relationships. not quite what you think. So I'm going to open up a new Power BI. I've already got my table that I actually want to show, which obviously you're probably thinking that doesn't look very interesting. It's only a list of numbers. But so how did I actually get those list of numbers? We'll see it's something interesting with, well, I think interesting in a minute. So I went to the data view, and I actually wanted to generate a new table. So in order to generate a new table, I can go when I find it, you've got new column there. I always get lost in here. Always get lost. Okay, so we can go new table. So we want a new table, and I'm going to call this new. I'm just going to call it new 10. It'll be kind of obvious why I'm doing that in a minute. I want to generate a table, but obviously I've got to have some sort of data to put in it. So Power BI's got this function called generate series, and I'm going to start with 1. I'm going to go up to 11. Well, no, 10, because I've called it generate 10. And I'm going to go in increments of 1. So generate my table. I've got my table there, and I'm just going to change that first column name. I'm just going to rename it. I'm just going to call it 10. And then I might want another table, so I'll just do exactly the same thing again. I'll go to new table, and I'll call this one 11. And I will generate some numbers again. And this time, instead of going to 10, I'll simply go to 11. Well, I'll go in steps of 1 again. So I've now got another table. And instead of calling that 11 with the value in there, I'll change the name of that. In a minute. Work. Just change the name of that because I don't really want it called value. Probably spelled 11 wrong. Spelling ain't my strong point. Okay, so that's cool. So I've got them 2 new tables. So I'm going to go back over now to my canvas, and I'm going to get a table. No, before I do that, what I'm going to do is I've got these 2 tables here. I don't want to summarize those when they go into my visual. I'm going to say don't summarize. And in the new 10 as well, I'm going to go same thing, click on the table, and I'm going to say don't summarize. Okay. And then I'm going to choose myself a table visual, and I'm going to drag on, or I'm going to put in there my 11 numbers. So I've got 11 numbers in there, and that's great. And like now I want to go, so I think I'll put my 10 numbers in there as well. And I get a problem. And it's like, hang on, why have I got a problem? So the problem is I've just created 2 tables, and I was able to manipulate them in obviously the Power BI interface, but there's absolutely no relationship between these 2 tables. And so Power BI is going, I'm trying to produce some DAX to look at these 2 tables. I have no idea how they generate. So I'm going to give you an error, and it's going to ask you to fix it. So it's going to ask me if I want to put a relationship in, and I do, but I'm not going to do it there. So I'm going to just remove those tables. So I'm going to switch over to my relationships view now, and I've got the 2 tables there that I had in originally. But now what I'm going to do is I'm going to go to my 11 table. Hang on. A bit too much going on here. Actually, I've done this previously, so I put my relationship into the 2 tables I already had. Now let me just click on that relationship. Now, when I created this relationship, it had different values in the properties. I've changed some of them. So I have changed this cardinality from, I think it was 1 to 1, it got put in as. I've changed it as many to 1. And you can see like there's a one side there, which is the 11 rows, and there's a many side there. That should actually be 10. I'll change that in a minute. And we can also see that the cross filter direction. Now, this is a big one. When you put relationships in, by default, they go to both. You actually want to probably change that to single. So you want to set that up. So effectively, I've got my 11 row table, and that should be 10. And let me change that back to 10. Anyway, let me go back to my design surface. And now I've actually put them in this visual, exactly like I had before. But now I've actually got a relationship between them. And you can see that in one side, I've got 11. And I've got 10 in the other side. And this one here there's nothing in it. And it's like, why is that? What's it doing? Is it doing a join? Is it doing an inner join? Kind of after giving this a bit of thought, and obviously looking at some of the syntax we showed before, it is kind of obvious what's happening there. So we've done a left outer join from our 11 table to our 10 table, and clearly we've got 11 rows in one side and 10 rows in the other side, and we've got a blank value there. And I'm thinking, well, makes sense. Now, because if I did this in SQL Server, I'd expect that to be a null, and it looks to me like that may well be a null. It's there. But after a bit of tinkering around, I found that this is in fact called a blank. So my next logical conclusion is that a null in SQL equals a blank in tabular. And I'm like, okay, that's a fairly standard conclusion I've come through. Let's test it out. So just going to refresh your memory on on nulls. So we got two nulls here. I set money amount 1 to 1, money amount 2, that should say amount. Told you by typing or my spelling wasn't too good. So if I add two nulls together, I get a null. Sorry, we're going to have to obviously include them. Obviously, a null and a null is a null. And if I want to see if one null is equal to another null, we'll have a look. Obviously, print out the message. They're not equal. So a null is never equal to a null. And if I add 1 to the null, I obviously get null. So I remember when I was a budding developer, someone explaining the concept of null to me. And they explained it like this. They were like, how much money have you got in your pocket, Martin? And I'm like, well, I don't know. I've got some money in my pocket, but I don't know how much it is. And they're like, okay, what would I record that value as? And I'll record that value as null. And then said to someone else, how much money have you got in your pocket? And I'm like, same thing. I don't know. What should I record? I'll record it as a null. Okay. So if I add those two values together, I've obviously got another value, but I don't know what that value is. So that value's completely null as well. And of those three null values we've got, none of them are the same, because two people have got money in their pockets, but they don't know how much. And if we add two values that are unknown, we're going to get another unknown. So null plus null equals null, and anything plus a null equals a null. So I'm now expecting exactly the same behavior from Power BI. So, okay, so what I'm going to do here, just going to diverge a little before I get into that. I've created a table here. Actually, before I will come back to that in a minute, and we'll go to this one first. So I've pretty much done the same as what I've done in the last demo for T-SQL. I basically said I've got a 1 and I'm adding a blank, and I'm kind of at the minute assuming this blank is a null. So I'm accepting I'm probably going to get a blank back, but then I run it and I get a 1, and I'm like, what's going on? So 1 and a null should have been a null, but this is blank and it's got a blank. So I then put a string in, and This is quite cool. This is DAX Studio that I'm using here, and you can see the results pane below. It's got tabbed column here. So um, syntax 1 has gone in low 1, and then I go to syntax 2, and it's given me Martin. So so clearly these are not the same as a null. So effectively a blank is, well, a blank is not a null. So what is it? Here it seems to have been a 0, because 1 plus something that equals 1 is going to give me 1. So it's a 0. And here it appears to be a blank string. And that's kind of exactly what I've got. So I want to take that concept a little bit further, and I want to have a look at some values. So one of the things I would suggest if you're going to try your hand at DAX and Tabular is forget about Power BI entirely, and try and, well, not entirely, but try and do most of your stuff within, say, the DAX viewer on Power BI, or more commonly within DAX Studio. So basically, I've used a define keyword here that we've seen previously, and I've defined a table. So this is how I might define a table in DAX Studio. Now, just to be clear, this table is kind of a local table. It hasn't gone into any sort of model. I am actually connected to a Power BI report here. I press connect, and I've got a Power BI report open that was open previously. And I've just basically connected to it. And just basically connecting to a Power BI report is going to allow me to use the DAX engine of that report. And that's all I need to do. I just need to use the DAX engine. So I've created a column here. Sorry, created a table, not a column. And it's got a few things going on here. So I've defined column 1, 2, and 3. Bit of a strange syntax for defining things. I know. I defined the columns up front, and then I defined the values inside these squiggly brackets. So I can just evaluate from there. We can see in my first query there, well, actually, what I'll do there, I'll just go evaluate, and I'll just call it test table. When I spell evaluate right, show test table, so I can just evaluate that. And that's basically select all from my table. So it's giving me my table back there. And then for our second, well, I'll actually get rid of that now so that the numbers line up. So we've got 1, 2. So for our next one, I've said where column 3, so this is column 3 here, is equal to nothing. And we can see that, you know, there's not a 0 in any of those third columns at all. So let's run that. I'll have a look at number 2, and we can see it's returned every single column. So unlike SQL, the blank seems to be it equates to a null if the column, because that column is an integer. Now, if that column were a string, and I was to ask for a blank string, which I actually do further down here on number 5, I've said, you know, filter, go to our table, and select everything where column 1 is in fact an empty string. And in number 5, basically got where column 1 is an empty string. So the first time I seen this, I thought it was really odd. In fact, so odd that I thought I'd done something wrong, I'd hit a bug, I'd done something. Because to tell you the truth, I was experimenting. I wasn't really going away and reading documentation about it, although in the end, obviously, I had to do that. So a blank is not the same as a null. So you might get a null in a database. You're not going to get a null in Power BI. You're going to get a blank. And all the joins in the relationships are all left outer joins. So it will, and kind of that makes sense, because in in a data warehousing world where you're joining facts and dimensions, you're going to be doing a lot of left outer joining. Most data warehouses would put in an unknown row. They wouldn't have that blank, that null or that blank going on. Anything that was null, they'd update to something like -1 and call that row unknown, and get that back like that. But in case you hit something like that, that's what is happening here. So let's go and have a look at some more of our code. So we'll go from the current slide and we'll say relationships. Okay, so to wrap that up, the database, in a database, we've got constraints. We've got primary keys and we've got foreign keys, and we make a linkage between them two. And they are constraining the data that goes into those tables. That's not the same in DAX. We've got relationships, but those relationships are purely relationships. They don't constrain anything. They don't stop different values going into the table, although we do only load at one time. But you could have values in one table on in another table. The relationships are purely there to allow the Power BI engine to find its way between tables. So that's kind of one of the obvious things there. Laying things out in a star schema is very, very much encouraged in as it would be in data warehousing, like a Kimball style data warehouse. And so laying them out like that, you can see we've got our one to our many, our one to our many, fact table in the middle, our one to our many, and our date, our one to our many. So you can lay them out like that. Alternative ways of laying them out that I've seen quite a lot of people adopting would be like the fact table down here. And obviously you might have more than one fact table, and all the dimensions up the top and kind of flowing downwards. So you've got from one to many, from one to many. And so, yeah. Now you see this around here, we got a kind of a snowflake dimension. Obviously that's a one to many and then a one to many. It's not a many to many, as you might expect in a traditional transactional database. What I'd suggest you should do in this case is try and merge those two tables into one. So you've just got like just a single one to many. As you go through these dimensions, following a pathway, you can see they've all got an arrow here. That will filter go in that way, filter go in certain ways. And that it's not going to cause you a problem in a small model like this, but when you get to bigger models, and you start refining, say, these relationships to go in multiple directions, because you can define these relationships to go in multiple directions, you might start getting a problem. So the advice that seems to be out there from people like SQL BI and Microsoft, and that is, star schema, one-to-many relationships, you kind of stick to that, you're going to be cool. So let's get on to some other things that I kind of think are really crucial to know, and when you're going from the SQL world to the DAX world, to not get caught out by. I'm just going to kind of list some of these because they're probably a little bit too complex to dive into. Right now, if I was to do demos on all of them, we'd probably be here till about 3 o'clock. But row context. So you may have heard of two contexts in tabular models. There's a row context and a filter context. So as the name might suggest, in a row context, it's going row by row by row by row. And there's and if you don't have a row context in your query, there are certain operators that will implement it for you. So you will get a value from a particular row. So if you want to retrieve a value from a particular row, you're going to need a row context to be able to retrieve that. And things like, we can do sums and averages and that in T-SQL. And you can do sums and averages in DAX also. But if you want to average, say, two columns that are joined together, you actually need a row context to do the initial mathematics to multiply them rows or add them together or whatever. So you essentially want two values from the same row, add them together, do a sum or an average or some sort of aggregation over that value. And so they've added these things called X iterators. So when you see something with an X on the end, it normally means that it's going to add that iteration function that you can then take advantage of. So I guess the most obvious one of these would be when you create a calculated column. It's going to just add two values in a row, and that's like the initial row context. Now, you need to be aware of the row context itself, because when you come to use calculate, which we'll talk about very soon, that context might change. And so if you need a value for a row, you will, not always, but mostly, you'll need them for aggregation too, and you'll need them to drag to get a value from the row. The next one we're going to talk about is like a filter context. And this might seem obvious, but for DBAs or developers, and you want to filter. So you want where, or you want having, or you want something like that. And it's like, well, we can just use that, can we? Like we'd use it in T-SQL. Well, your filters can be defined outside of the query. Obviously, you can define them inside the query itself. But if you think about something like Power BI, like a report, you've got things like slices and buttons you click on, and they all change what's called the filter context. And then that filter context gets applied to the main query. And we've seen when we looked at the generated code, we've seen some variables there, and that they might be used to set up this filter context. And then, of course, you've got the filter context that you've implemented in the query itself, which might be based on a value for a row or whatever it is. And so you've basically got to take the union of all those filter contexts and decide what filter context is being implemented on the complete set of filters. So you can define things in Power BI reports, and obviously you can implement them physically in your code. But there is a little bit more to this. And that's what they call context transition. And these three things, row context, filter context, and then context transition, are pretty much key to the whole DAX thing. And they don't exist in, well, obviously the row context is quite fundamental. I mean, most DBAs, developers, shouldn't have any problem at all understanding the row context. It's simply just row by row, row by agonizing row, as you might say. The filter context is more of an abstract concept, so to speak. And when you've grasped that, you then need to probably grasp this context transition. So you think you've identified all the filters. So you've got, obviously, your filters in your code, your filters on your report page, and you might have actually added filters using this function called calculate. Now, the calculate function itself is like no other function we've got in T-SQL. Obviously, in a T-SQL query, we can add as many filters as we like. We can put where clauses in, we can use and all, or whatever. The one thing calculate can do in DAX that we can't do in SQL Server is it can actually change that context itself. And that can mean it can actually remove filters. So as well as adding to filters with a line of code, you can actually remove a specific filter that you might not want to be there. And that might aid your visualization. And that's kind of a really odd concept for a SQL DBA or developer to grasp. If you want to remove a filter in T-SQL, obviously you've got the option of deleting it, or you might put a statement around it. You might use dynamic SQL, some sort of case statements. But basically you do some sort of trickery to get rid of that filter if you wanted to like get rid of it at runtime, whereas you don't have to do that in DAX. You can use the calculate statement. There's some syntax there called remove filters. That's one thing that will remove them. There are other things that will change them or remove them. And so that's where the calculate statement comes in. But the main thing we're talking about here is context transition. So we've got our row context and we've got our filter context. Now, the row context that has existed needs to be transferred into a filter. So that's what the context transition is all about. The row, the context that might exist on that row, is transformed into a filter using calculate. And then you get obviously multiple filter context. The row context is gone, and now the filter context is being applied to the entire query. And that is a totally alien concept to the overwhelming majority of SQL developers or SQL DBAs. And it's also something that you're probably not going to understand. I know I might not have done a great job of explaining this, but probably something you're not going to understand by simply experimenting or looking at other people's code or just Googling. What you're best doing is go into somewhere like SQL BI or the Microsoft site, but I'd recommend SQL BI, and reading in depth all about these row context, filter context, context transition. SQL BI, I've got a great set of videos out there. I think they're called like DAX 101, and they just go through all this stuff in kind of quite basic detail. Obviously, they then sell courses on top of that, and you can dive in and get them. But it to me, well, this wasn't for me anyway, something that I'm going to like naturally get just by looking at the code. It's something that you've really got to read and read again. And so those three things are pretty crucial. The other thing that I'd advise you to look at if you're going to dive into DAX in a big way is something that I didn't really hit on this until I was I thought I was coming to the end of my DAX journey. And I've since reevaluated to say, you're not really ever going to come to the end. You're literally always going to be learning about that, especially the situation that I'm in at the moment, where I don't really do DAX much, but I get asked to delve into it occasionally. And then I'm kind of almost relearning what I've already learned, which isn't probably a great place to be in. But an expanded table. So it is pretty much a core DAX concept. And we've got the concept of a base table, which might be. So I'll explain what it is generally, and I'll explain the concept of base tables or related tables. So as the relationships flow on from one table to another, the kind of the virtual table, as it were, gets bigger. So if you can imagine you've got 3 rows in one table, and that's linked with a many-to-one relationship to another table that's got 10 rows. You've then got 3 rows plus 10 rows, which equals 30 rows, and so on. And it's kind of getting bigger. And when you run your query, basically uses a full outer join between tables, but they only flow in one specific direction. And so the result set that you're querying against has obviously grown exponentially. Well, maybe not exponentially in smaller things, but it's definitely grown. It's got more rows and it's got more columns in. And that can throw you in a big way. So I would, if you're planning to learn DAX in any kind of depth, as well as exploring those context transitions and filter context and row context, go and have a look at this expanded table concept. I'll just click on this link down here because I put this in down here. So you can see here that, the table, there might be 3 in there, and that's joined to 2 in there. And then it's made bigger tables around the expanded set of like rows and columns. So this isn't a big article. And there's lots of articles like this that explain the row context, the transitions and all that. And they're really worth reading and going into in a little bit of depth. But those things that I've mentioned there, probably what I consider that the most probably the most important things. There's a whole load of other things which I obviously can't do justice for on Mac 2. and might not have even done justice to the things that I've mentioned already. And also the data source is important. So the expanded, if you've got multiple data sources, that these things don't cross data sources either, which is probably true in a lot of other cases for things as well. So there's a lot of different variables coming into play and concepts that are a little bit alien to the DBA or the developer. So this wants to round off with a very simple quiz. Yeah, obviously you don't have to fire answers to me, but I'll tell you the answers as we go along. So it's just basically to do with Power BI desktop files, really. So I've got a bunch of tables here. Well, sorry, I've got a bunch of PBIX files, so Power BI desktop files. And the first one basically contains a table that has 2 rows in it. It's got like 2 columns in it, first name and last name, and it's got 2 rows in it as well. And I'm just going to ask kind of, what do you think is the biggest file? What do you think is the smallest? So obviously don't have to type in or shout out, just like might surprise. And then we've got another file. It's got 2 rows in it again. And this time we've got a start date and we've got an end date. But again, it's just got 2 rows. So 2 rows in both of those. The next thing we've got is a 1 billion row table. So this took me absolutely ages to import into Power BI Desktop. Basically designed a 1 billion row table in Azure SQL and imported it into Power BI Desktop, and it took me an extremely long time. I then made a 20 million row table, and I imported that into Power BI Desktop. And I kind of just a little quiz. I've done this somewhere else as well. It's like, which one of those is the biggest and which one is the smallest? And the results are very, very surprising. So the column with 2 rows using the first name and last name is in fact, well, sorry, I didn't know that was going to come up. The one with the start date and the end date is 25 megabytes. The one with the first name and the last name is 24 megabytes. The 1 billion row table. Now, it's a bit of a debate here. What's going to be bigger, the 1 billion row table or the 20 million row table? So the 1 billion row table is only 38 kilobytes big. I actually got these on my file system somewhere. But the 20 million row table is really 553 megabytes. And I really done this to like kind of emphasize 2 of the really big concepts here. So when we've got a table in Power BI that implements a date, and we're just using like the default settings, we will get, for every column that implements a date, we actually get a date table, an invisible date table created. And that, obviously, the more of those you've got, the more that's going to expand your model. And so the guidance there is turn that off, turn that feature off. That's on by default. Just implement your own date table and use that going forward. Not nearly every model I've seen has got a date table in it somewhere. So, there's lots of date tables around. Picking one, importing it into Power BI, or you're using it, whatever model where you're using, use it and turn off the defaults. The 2 rows for the first name and last name, that's pretty small as well. They're obviously both text. However, why is the 1 billion row table like tiny? And why is the 20 million row table really huge? Well, bit of trickery going on here. The 1 billion row table only contains 2 values. It contains a 1 and a 2. So obviously there's 500 million 2s and 500 million 1s. And this kind of just emphasizes to me the compression ratio that it can be applied to data that's obviously the same. It's obviously compressed that a lot, and it's only 538 kilobytes big. So why is the 20 million row table like half a gig big? That's because there's 20 million GUIDs in there. So those 20 million GUIDs obviously can't be compressed because they're all basically different. So we end up with a massive file. So, all right, it's just meant to demonstrate some concepts of Power BI and that there. But like I say, I probably couldn't do this subject justice in the 1 hour. I tried to just give some guidance for people who want to delve into DAX in a big way. I didn't really have any real need to learn DAX other than being curious. And kind of this journey has kind of taken many years. And it's not something I've been on constantly. Occasionally, I'll sit next to people in work who are like Power BI developers, and I just chat to them, and they'll tell me interesting things about Power BI, and I'll be like, that's not how it works in a database, and explore it a bit more. And then my curiosity got the better of me a year or so ago, and actually did go on a DAX course. But of course, I haven't done that much work with it ever since, and I've kind of lost a lot of that knowledge. But hopefully, I've passed on some interesting things. And thank you very much for listening to me. And I'll hand back to Warwick.
Thank you, Martin. Excuse me. We do have a question for you. Ashok has asked, if by default date, or I think it might be, if my default date table is hidden, and as suggested, create your own table, then why do we have a default date table?
Well, I would guess that there's actually a setting in Power BI to create the default date tables, and you need to turn that off. And if what he's saying is he's left it on and created a that he's created his own date table, and then obviously the default behavior will still apply. I'd be surprised if that had been taken off and there was still tables created. Possibly it could have been on in the first place. A few date tables were created then, and then it was turned off, and maybe date tables remain there that shouldn't remain there. That's probably all I can think of at the moment.
Okay. Ashok, if you want to come off of mute, if you want anything further to ask of Martin for clarification, or if that's all good, give us a thumbs up while we're waiting for that.
Hey, Martin, how are you?
Hey, Ashok, how are you, mate?
Very well. Look, this question which you have answered, suggested not to use the default date table. I know how to switch it on and off. But as you said, I think one of the biggest reason could be that default table might change from one version of the Power BI to other one. So all the model of visualization which has been built using the default date table, that might possibly you make it incorrect visualization. So using our own date table means that things will be sure that things will not change.
Yeah, I mean that's a fair. I don't know. That's a reasonable assumption. That there may be date tables there at one time, and obviously they're being used. I'm not 100% familiar with what exactly would happen if you turned it off at any one particular time. But yeah, I'd just go hunting around there and see. Maybe try and get rid of the date tables that you don't need. Don't know if you'll be able to do that, or yeah, it's an interesting concept.
Thanks, Martin. Really, I enjoyed this session, as well as you had this same session earlier, and I would have been happy had you repeated your previous session as well.
Oh yeah, nice one. Thanks, Ashok. Yeah, I did a similar session to this at SQL Saturday, Data Saturday last year. Yeah, it was kind of quite cool there because I had Darren Goswell was in the audience, and he is actually the developer of DAX Studio, and yeah, he was quite cool in being helped me out with quite a few DAX concepts.
Okay, good on you, man. Thank you.
Thanks a lot.
Well, thank you, Ashok. Does anybody else have any other questions for Martin before we finish up for this month's session? Feel free to either put it in the chat window, raise your hand, and you can come off and ask the question in person to Martin if you like. So while you are thinking about that, a big thank you to Martin for giving up his time today on taking us through from SQL to DAX, and for everybody for joining us today. As I mentioned at the start of the call, this session has been recorded and will be made available on the Data Platform Downunder YouTube channel. If you don't already have it, I have put the link in the chat window, so feel free to take a copy of that link, join up to the YouTube channel, and continue your learning. So I'll just duck across to the chat window. Okay, so we've got some praise for you, Martin, so much appreciated. Great presentation. So always good to get feedback as well as questions for our sessions, because Martin, I'm pretty sure that you can agree with me that as a presenter, looking for feedback and tips or even good questions to go and think about other things that can improve your session is always a good and welcome approach.
Oh yeah, absolutely, Warwick, absolutely. I mean, I guess you always like, even when you create something and you finished it, you're always like, yeah, I can make that better.
Very much so.
Yeah. Okay. Thanks for hosting me anyway.
You're welcome. So if there are no other questions, then thank you all for giving up your time and being part of this month's session. We have got one more session for the year. So it's not a technical topic per se, but very much still in the realm of, as technical people, a very good session for you to come along and register for. So if you haven't already, you will find that on the Data Platform Downunder website, where you can register for that session with where we'll have Cindy coming along and talking to us next month. So with that, everybody, enjoy the rest of your day, enjoy the rest of November, and I look forward to seeing you all in a month's time.
Well, cheers all. Thank you.